over 7.5. If HO is equal to size of object, 2 cm over HO is equal to 30 over 7.5. HO is equal to 2 times 7.5 over 30, which gives us 0.5 cm. Therefore, size of the object HO is equal to 0.5 cm. Example 2. An object 1 cm high placed on the axis 15 cm from a converging lens from an image 30 cm from the lens. What is the size of the image? Solution. Height of image over height of object is equal to image distance over object distance. That is, height of image over 1 cm is equal to 30 cm over 15 cm. Therefore, height of image is equal to 30 times 1 all over 15 is equal to 2 cm. Therefore, the size of the image is equal to 2 cm. Example 3. If the magnification of a virtual image from an object 10 cm from a convex lens is 3, calculate the focal length of the lens. Solution. Object distance U is equal to 10 cm. Magnification M is equal to 3. Here, V, image distance over object distance U is equal to M. Therefore, V over 10 is equal to 3. Making V the subject of the formula, we have 3 times 10, which is equal to 10 cm. 1 over object distance is plus 1 over image minus image distance V is equal to 1 over focal length F, virtual image. That is 1 over 10 minus 1 over 30 is equal to 1 over F. The LCM is 30. 10 divided by 30 will give us 3. 30 divided by 30 will give us 1. We have 3 minus 1 over 30, which is equals to 1 over F. That is 2 over 30 is equals to 1 over F. Therefore, making F the subject of the formula, we now have 30 over 2, which is now equal to 15 cm. Therefore, the focal length of the lens is equal to 15 cm. Example 4. A lens of focal length 12.0 cm form an upright image 3 times the size of a real object. Calculate the distance between the object and the image. Solution. Object distance is equal to U. Image distance equals to V, which is equal to V over U is equal to 3. That is, V equals to that image distance is equal to 3U. Focal length of the lens is equal to 12. Applying lens formula, 1 over image object distance U minus 1 over image distance V is equals to 1 over F, focal length, which is the, in bracket, virtual image. Substituting the values, we have 1 over A minus 1 over 3A is equal to 1 over 12. Their LCM is 3U. 3 divided by 3 will give 3. 1 divided by 3 will give us 3. Or U divided by 3 will give us 3. Why 3U divided by 3 will give us 1. 3 minus 1 over 3U is equal to 1 over 12. Therefore, 2 over 3U is equal to 1 over 12. 3U is equal to 24. U is equal to 24 over 3, which is equal to 8. Distance between the object and image is equal to 24 minus 8, which is equal to 32 cm. Electromagnetic wave. Electromagnetic waves are waves that do not require material medium for their propagation. Table 3.1 shows the wavelength and frequency of radiations in electromagnetic spectrum. Name of radiation, we have wavelength in meters and frequency in hertz per seconds. Gamma ray, the wavelength in meter is 10 raised to power 11, while the frequency in hertz per seconds is 10 raised to power 18. Another radiation is X-ray. The wavelength is 10 raised to power minus 9 meters, while the frequency in hertz per seconds is 10 raised to power 16. Another radiation is ultraviolet. The wavelength in meter is 10 raised to power minus 7. The frequency F in hertz per seconds is 10 raised to power 14. Another radiation is visible light. The wavelength in meters is 10 raised to power minus 6, while the frequency in hertz per seconds is 10 raised to power 12. Another radiation is infrared heat. The wavelength in meters is 10 raised to power minus 5. The frequency in hertz per seconds is 10 raised to power minus 10. Another radiation is radio wave. The wavelength in meters is 10 raised to power minus 2. The frequency F in hertz per seconds is 10 raised to power minus 4. Example 1. The frequency of electromagnetic radiation is 10 raised to power 20 hertz. If the speed is 3 times 10 raised to power 8 meters per second, what A is the wavelength of the radiation? B, the type of electromagnetic radiation will it be? Solution. Applying the formula V is equal to F lambda. Therefore, lambda is equal to Vf over F, where F is equal to the frequency of electromagnetic radiation. V is the free space velocity. Lambda is the free space wavelength. But V is equal to 3 times 10 raised to power 8 meters per second, and F is equal to 10 raised to power 20 hertz. Therefore, lambda is equal to V over F, which is equal to 3 times 10 raised to power 8 over 10 raised to power 20, which will now give us 3 times 10 raised to power minus 12 meters. Example 2. The wavelength of ultraviolet radiation is 400 millimeter. If the speed of light in air is 3 times 10 raised to power 8 meters per second, calculate the frequency of the ultraviolet radiation. Solution. Light velocity V is equal to 3 times 10 raised to power 8 meters per second. Wavelength of ultraviolet radiation is equal to 400 nanometer, which is equal to 400 times 10 raised to power minus 9 meters, which is from V equals to F lambda. Therefore, making F the subject of the formula, we have F equals to V lambda, which is equal to 3 times 10 raised to power minus 8 over 400 times 10 raised to power minus 9, which will give us 7.5 times 10 raised to power 14 hertz. Example 3. Radio wave has a velocity of 3 times 10 raised to power 8 meters per second. A radio station sends a broadcast on a frequency of 800 kilohertz. What is the wavelength of the broadcast? Solution. Velocity V is equal to frequency F times wavelength lambda. Therefore, lambda is equal to V over F. Lambda is equal to 3 times 10 raised to power 8 all over 800 times 10 raised to power 3, which will give us 3.75 times 10 raised to power 2, or 375 meters. Application of light wave. Formula involved in optical instrument. 1. Compound microscope. Magnification M is equals to, in bracket, D over F1 minus 1, in bracket again, times, in bracket, V over F1 minus 1, where F1 and F2 are the focal length of the lenses, and D is the lens distance of distinct vision, D from the eyes. 2. Astronomical telescope. magnification m is equals to FO over